All right, so moving into using the discriminant. All right, using a new word here. The discriminant is a number. It is a number that gives us some information. It is represented by the expression b squared minus 4ac. Hopefully you recognize that expression. Where have we seen it before? It was the expression inside the radical in the quadratic formula. So you've been dealing with it quite a bit. What this number does is it tells us the number of solutions. How many solutions does the quadratic have? Okay. What I want you to make sure you see is it will not tell us what those solutions are. It is not a way to solve a quadratic. A lot of people think, oh, can I solve the quadratic using the discriminant? No, you can't. It just gives you some information. Okay. What information does it give you? Let's scroll down here a little bit. If the discriminant is positive, what I mean by that is the number under the radical is positive. Well, if the number under the radical is positive, you should remember from when we did the quadratic formula, you're going to get b plus or minus a positive number, right? That's going to give me two solutions. Okay. If the discriminant is negative, what I'm saying is the number under the radical is negative. And if the number under the radical is negative, what does that mean? You can't take the square root of it, which means this would have no solutions. Another way you'd say it would be 0 solutions, okay? Last one, if the discriminant is 0, all right? The number under the radical is 0. Then the quadratic will only have one solution. And here's why. Let's just say b is -5. So we get -5 is 5 plus or minus the square root of 0 over 10. Let's just say that. Okay. Well, when I break it up, square root of 0 is 0. So I'd have 5 plus 0 over 10. And I'd have 5 minus 0 over 10. 5 plus 0 is 5. 5 minus 0 is 5. You get the same number, which is why you would only have one solution. Okay. So that covers all the possibilities, positive, negative, or 0. So it's either going to have two solutions, one solution, or 0. So let's figure these out. Find the number of solutions for each quadratic. All right, so first one, it's just b squared minus 4ac. Unfortunately, it still has that tricky part with the minus 4ac that a lot of people still mess up on, but it doesn't have all the other stuff on the outside. So it's just 12 here, a here, c here. Okay. 12 squared is 144 minus, I still do this even on the discriminant. 4 times 5 is 20. 20 times -32 is -640. 144 minus that, which is actually 144 plus that, is, what is that, 640, it's 784. When I'm asking you the discriminant, I need to actually see that correct number. That's not my answer, but I just want to make sure that you are interpreting it correctly, because you have a 1 in 3 chance here. So how many solutions does this have? Well, that number is positive, so that means there's 2 solutions. Okay, I don't know what they are. All I know is it crosses, this parabola will cross the x-axis twice. Next one, b squared minus 4ac. B is 3, a is 4, c is 7. So I think it's pretty obvious. 3 squared is 9, minus 4 times 4 is 16. 16 times 7 is 112. 9 minus 112 is -103. So if I have the square root of a negative number, I would have no solutions. Okay, doesn't really get too tricky. There is a little bit you want to watch out for, like on number 3. I need to get 16 to the other side. You've done this before, nothing tricky here. But you do have to watch for it. So I got x squared minus 8x minus 16. Okay, if you don't do that, you're going to have the wrong sign for your C value, and that's going to cause your discriminant to be off, but not a hard step, hopefully. B is -8, A is 1, C is -16. And I did this on purpose. I'm going to show you if I had not done that, what would happen. -8 squared is 64, minus 4 times 1 times -16 is -64. 64 minus -64 is 128. This one has two solutions because that number is positive. Now let's say I didn't move 16 over and I left it as positive 16. Then that would make that positive 64, which would equal 0. And then you would say there's only one solution. So it does affect, having the right sign has a huge effect on these problems. Okay. Last one, it's equal to 0. So B squared minus 4AC. B is -12, A is 4, C is 9. -12 squared is 144, minus 4 times 4 is 16. 16 times 9 is, I believe, 144, and it is 144 minus 144 is 0. I will see a bunch of people get that and say, oh, no solutions. No, when it's equal to 0, I showed you earlier, that means there's one solution. It will touch the x-axis and turn around. Okay, that's what you're going to be doing mostly today. However, there is another way you can use it. A toy rocket is launched off of a roof with an initial velocity of 70 feet per second. The height of the rocket during its flight is given by that equation. All right. Will the rocket ever reach 100 feet in the air? And explain. All right, to figure this out, we need to put 100 in for H. I'm asking if it's going to reach an H value of 100 feet. Okay, so when you do that, you get 100 equals -16t squared plus 70t plus 21. However, we have to have a quadratic equal to 0 before we solve. So we need to move that 100 to the other side of the equal sign. So I need to move 100 to the other side of the equal sign. Now it does combine with something already over there. Combines with a 21. So nothing changes on A and B, but C becomes 21 minus 100. It becomes -79. This equation right here that I'm putting a star beside, that equation is only for when the rocket is specifically 100 feet off the ground. Let's say I wanted to know when the rocket was 50 feet off the ground. My equation is going to look different. It's going to look like, well, I'll put it right here first. 50 equals negative blah, 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 blah. But then I have to move 50 over, right? And I would get 0 equals -16t squared plus 70t. Again, A and B don't change. But then it'd be 21 minus 50, which would be -29. It would be a different equation, okay? Which would potentially have a different discriminant. Okay, so they're different problems based on how high you want to see if this is going to reach. All right, now what we can do is we can use the discriminant with this equation to see how many times the rocket will reach 100 feet. So I'm going to go back up to the start equation, B squared minus 4AC. Okay, B is 70. A is -16, C is -79. So 70 squared is 4,900 minus, I'm gonna go to my calculator here. 4 times, oh, I should probably do this because I want to be consistent. Negative times negative is gonna be positive. So this is gonna be a positive number. So 4 times -16 times -79 is 5,056. 4,900 minus that is -156. So what can I conclude? Will the rocket reach 100 feet? No, it will not. I'm gonna have to clear all this and I'm gonna go down and give an explanation. The rocket will not reach 100 feet because the discriminant is negative. Meaning the rocket can't reach this height. It's a weird T, sorry. All right, if the discriminant were positive, it would reach 100 feet. It would actually pass 100 feet. If the discriminant were 0, it would reach 100 feet, and that would be the highest it could go. That's how you use the discriminant in a different situation. That's it. And one lesson left, and we'll be done.